Okay, this is the video for the review session, review problems for exam number 2, problem number 2. So we look at this and we're looking for steady state error in this problem, steady state error for a unit step and steady state error for a unit ramp. Okay, so we look at the system and we notice there's going to be 2 loops, all right? So here's an inner loop. Okay, and so we could call that G1. Once we had G1, then the transfer function, the closed loop transfer function, is going to be G1 over 1 plus G1. And we could also get the closed loop error signal, or the error transfer function. E over R would be 1 over 1 plus G1. Okay, so we just need to find G1. And G1 is going to be K1 times 3 over S plus 6 divided by 1 plus K1 times 3 over S plus 6. These are just our normal feedback rules. So then I need to multiply by K2 times S. All right. So put a box around it. That is G1. All right. So next, we need to calculate the steady state error. All right. So to get that E steady state, that's going to be equal to the limit as t goes to infinity of E of t. All right. Which is the same thing as using the final value theorem. Limit is s goes to 0 of s e over r multiplied by r. Okay, so we know e over r is the 1 plus g, so writing that down, we have s 1 over 1 plus g1, and then since this is a unit step, R is known to be 1 over S, so I do 1 over S, and these cancel. And basically, I get my steady state error by evaluating this to be 1 over 1 plus G1 of 0. All right, so I go back to G1, and I'm looking at plugging in S equals 0. All right, so when I plug in S equals 0, this is zeroed out. This is zeroed out. The K2 times S, that's zeroed out. So this whole thing goes away when I have that S equals 0. This whole part goes away. And I'm left with three K1 over 6. Okay, so this becomes 1 over 1 plus 3K1 over 6, and that's the same thing as, that's a 1/2 multiplied by 2, 2 over 2 plus K1. So that's my steady state error for a unit step. Okay, so that's a finite error, it's non-zero, and so this is type 1 system. And on the exam, here's what you should know. I'm sorry, type 0 system. Because it's type 0, what do we know about the tracking ability for a ramp? Well, we know it can't track a ramp with finite error. So the steady state error for part 2 by inspection, because it's type 0, is infinity. Okay, you could actually stop there. All right. If you were curious about how that works out, what's the math behind that? What we have here for a ramp is that R of S is 1 over S squared. So we plug into the same equations and we get ESS is limit as S goes to 0 of 1 over S squared times S divided by 1 plus G1. Okay, and so one of these S's cancels, And so I'm left with an extra s in the denominator. Okay, and so when I put that extra s in the denominator, you know, this number, when you plug in s equals 0, that's a finite number. It's non-zero. All right, so this whole term is non-zero, so I have 1 over s going to 0, so I think you can tell from this limit that the steady state error would be infinite.